All right, welcome everyone. Thank you so much for joining us today for the first of a series of educational workshops on film and flexible packaging, specifically designing film and flexible plastic packaging for recyclability, the what, the why, and the how. The Canada Plastics Pact and the US Plastics Pact are so pleased to bring this to you all today. So thank you again for your time and attention. A few quick housekeeping notes. We are recording this session, and the recording will be provided to everyone who has registered for today's webinar. For US Plastics Pact activators and CPP partners, you all will receive the recording and the slide deck. So thank you for that. Everyone is on mute. There will be time for Q&A at the end, sort of toward the end of today's session. But in the meanwhile, if something comes up, please do utilize the chat feature. For today's agenda, we will do a quick introduction to the US Plastics Pact as well as the Canada Pact. Again, I'm so happy to welcome everyone. My name is Emily Topaldo. I'm Executive Director of the US Plastics Pact for those whom I haven't had a chance to meet yet. We're going to dive into an introduction of films and flexibles, talk about why multi-material packaging constructions hinder our road to circularity, touch on the role of chemical recycling, talk about pathways to get to redesigning toward mono-material formats, get into some additional technical considerations, and then we promise to preserve time for audience Q&A. We do have a really packed agenda. Today's presenters, which we're glad to bring you all, I am here co-presenting with Cher, who will jump in just a moment with the Canada Plastics Pact. We also have Pierre Benavides, who is with Lichens as well as the CPP, Sarah Edwards with Eunomia North America, Paul Shorthouse, also with the Canada Plastics Pact, Rebecca Mick of Amcor, and Megan Byers with the US Plastics Pact team. And with that, I'm going to hand it over to Cher.
For our objectives today, hi everyone, I'm Cher Merriweather. I'm the Managing Director of the Canada Plastics Pact. For our objectives, how multi-material films and flexibles cause those technical and financial challenges preventing progress. Emily talked about some of these, the potential opportunities. Monomaterial films and flexibles are the preferred structure for recyclability, and how complex multi-materials and flexibles can be redesigned. So really exciting agenda today. I do not see the advanced slides, so if we can add that, thank you. I wanted to start by giving a little bit of context. So the US Plastics Pact and the Canada Plastics Pact are part of a global plastic pact network. And in January of this year, we had the opportunity and privilege to be a part of our first in-person session. And what an incredible opportunity in South Africa. All of our pacts are driven by 4 important targets. And so we had an opportunity to share our learnings, talk about the global treaty that is, of course, front and center for all of us, and to really think about how do we share the knowledge. But what was really important is our opportunity to participate in literally picking plastic off the streets in South Africa. And that's what you see the visual on the screen. We spent a half a day picking plastics. And what was really obvious to both the US team and myself when we were there was the sheer volume of flexibles that was on the ground and in the ocean. And what was really striking was that when the pickers were collecting, they were not interested in the flexible film because there was no market value. And so they really focused on the rigid plastics and just left the garbage on the streets. And so it was a real reminder that from a brand perspective, your products are sitting on the streets, and we really do need to address this front and center. So, Emily, back to you.
Thanks, Cher. So for those who may not be as familiar with the US Pact, really quickly, we are driving the national strategy or agenda on circular economy for plastic packaging in the US. We currently have over 135 activators, which is the term that we give our members. We are working from a strategic roadmap in 4 key target areas, focusing on reducing problematic and unnecessary materials. And you may be familiar with our problematic and unnecessary materials list that we published a couple of years ago. We have a handful of work streams that really do the work because our activators, our members, are the ones driving action toward our goals. We also put forward an innovation award every year to recognize commercial technologies to advance reusable packaging, recyclable design, compostable packaging and design, as well as refill. Collaboration is part of what we do, and having some difficult conversations, we find comfort in that, and that gets us really excited. And so this is part of the reason why we are so invested in the multi-material flexible packaging challenge and discussion to help drive solutions. Cher.
Thanks, Emily. To give you a little bit of context about the Canada Plastics Pack, we launched officially in 2021 and have grown to almost 100 pack partners. And our purpose is really about accelerating the elimination of plastic waste. And we have a vision of a circular plastics economy by 2035. And in order to do that, this is all about eliminating the unnecessary and problematic plastics. It is about innovating so that the plastics we do need, that we can keep them safely in the economy and effectively making sure that we're reusing, recycling, and composting them. And then most importantly is that those plastics that are circulating in the economy remain in the economy and out of people, animals, and nature. In terms of what you can count on us for, if we go just one slide ahead. In terms of what you can count on us for, we are all about bringing the people across the plastics value chain to the table. Emily touched on this as well. It's about having those tough conversations across the entire plastics value chain in a pre-competitive way so that we can tackle the challenges that cannot be done in isolation, that they can only truly be tackled when you are in conversation. And the flexibles is a really great example of that. To tackle the challenging and polarizing topics, and boy, is flexibles ever a challenging one. Our Canadian plastic pack partners put into the market 980,000 tons of plastic in 2022. And of that, about 47% of it was flexibles. And in Canada, only about 4% of that was recycled. So this is really one of our big challenges. And when we think about the plastics waste hierarchy, we know that source reduction is front and center, but flexibles present a really important opportunity. If we think about it from a food perspective, this is a material that extends shelf life, it prevents food waste. It's incredibly important. And when we think about the distribution of packaging, flexibles is extremely light. And so from a carbon perspective, it's an ideal choice. The problem that we have right now is end of life. And so the design, which is what we're going to talk about today, is so critical to that conversation. And so that's the challenging and polarizing topic of the day. In terms of what else you can count on us for, being that catalyst for real world ideas and innovation and scaling the ones that work. 2024 is a really important year for us where we're going to do a lot of work in terms of scaling innovation. We launched literally yesterday our first reuse accelerator pod. Super excited about that. Stay tuned for more accelerators, including hopefully one in the flexible space. You can count on us to use data to accelerate the elimination of plastic waste and support broader partners with their environmental, social, and governance priorities, making those strong connections to climate impacts and biodiversity impacts. We want to work with government to guide policy and incentives. We want to drive the business case for circular plastics, make sure that we've got a good, solid economic position and that we're supporting our partners in understanding the true economic cost of change. We are providing our partners with guidance, research, and expertise to support that circular economy for plastics. And finally, using science and data to make that a really informed choice and to measure and report on the impact that we're creating. Emily, back to you.
Thanks, Cher. We will touch on this again at the end, but just to note that this is the first of a series of webinars workshops and webinars that we have planned for 2024. We're starting sort of at the higher level and we'll get into more detail later. So just make a mental note of that and we will share more. I will get in trouble if I don't mention some of these last nuts and bolts before we get into today's content. So very, very important to both the US Plastics Pact and the Canada Plastics Pact. We take competition laws and antitrust guidelines very seriously. And so we ask that each participant comply with any applicable federal and state antitrust and competition laws that may be relevant to you. This includes not engaging in discussions or sharing information related to specific pricing or customer-client relationships, the ways in which you compete in the marketplace, or any other topic that's prohibited by applicable antitrust and competition regulations. So thank you in advance for adhering to that. Again, it is very important. We know sort of many of us span different parts of the value chain. I would also note for today, the Film and Flexible Workshop Series should not be construed as an endorsement of any organization by the US Plastics Pact or the Canada Plastics Pact. The US Plastics Pact and Canada Plastics Pact do not make any recommendations, representations, or warranties regarding any of the presenters' materials, products, services, or performance. So the views and opinions that you will hear today expressed in the session, as well as the slides and materials presented and statements, are those of the speakers, and again, don't necessarily reflect the views and official opinions of the US Plastics Pact or the Canada Plastics Pact. So thank you for listening to that. And I am happy to hand it over to Megan Beyer, who's going to get us started with today's program.
Sorry about that. All right, thanks, Emily, and thank you, Cher, for that great introduction to the session. We have quite a mix of perspectives on the line today, a lot of folks from different backgrounds and nationalities, but we have a lot in common to achieve the goal of circularity for film and flexible packaging. To help us foster the common understanding, I'm going to lay some groundwork on the role of flexible packaging, explain what we mean by multi-material and mono-material packaging, and then put some perspective around the scale of the impact that we can make through our voluntary commitments. So in a nutshell, flexible packaging is a container that can change shape. In some parts of the world, they're also sometimes called soft plastics, and these characteristics are useful for a few reasons that I'll touch on in a bit. When we talk about multi-material flexible packaging, we're talking about designs that combine dissimilar materials that are unable to be reprocessed together with the primary resin. On the other hand, mono-material flexible packaging structures contain predominantly one material, either polyethylene or polypropylene, and the remaining materials used are compatible with the primary resin when producing a recycled product. Important to note that mono-material is not the same as mono-layer and vice versa. Multi-layer packaging can be constructed with monomaterials, including compatible barriers and additives that are acceptable in our design for circularity guidance. Rebecca will tell us a little bit about that later on in the session, but for now, let it be understood that although multi-material and multi-layer are closely related concepts and terms that are sometimes used interchangeably, we aim to use these terms precisely in our session. While we're here, I also want to ground us in the focus of this session, which is designed for recyclability. I'd be remiss if I failed to acknowledge the role of reuse and compostability solutions that are in development and that exist in the marketplace. As the US Plastics Pact, we have developed guidance to help activators understand when a reusable or compostable solution might be appropriate for certain applications or contexts of use, but that topic is outside of the scope for this particular workshop, but it is within our mission. Okay, with the goal of recyclability in mind, you might think, and indeed some people have proposed, why don't we just focus on rigids? After all, we recycle rigid packaging every day. We know how to collect it, we know how to sort it, and we know it has value. And that's valid. At the same time, there are also valid reasons that producers may choose to utilize film and flexible packaging. On the front end, it provides tremendous functional properties for packaging applications and even some environmental benefits. For instance, it provides a high product to packaging ratio, meaning that you can use less plastic, fewer virgin natural resources to package the same amount of product. It doesn't shatter or dent, it's lightweight. It requires less energy and water to produce than heavier duty packaging formats. And flexible packaging can also save space in transportation and result in reduced greenhouse gas emissions across its life cycle. And this graphic provides a nice visual of how the light structure of flexible packaging works to its benefit. And sometimes it's also just the preferred way for consumers to access certain products. Any way you look at it, flexible packaging has its foothold in the marketplace, and we need to figure out how to manage it at the end of its useful life. There's a lot of it out there. The opportunity in front of us is huge. Within our scope as the US Plastics Pact, 37% of plastic packaging on the marketplace is represented by our activator companies. That's nearly 6 million tons of material that's within our scope of influence. And despite its lightweight, film and flexible packaging comprises nearly a third of that portfolio by weight. And in fact, multi-material flexible packaging is within the top 3 packaging formats, comprising 12% of our portfolio, following only PET and HDPE bottles. And this data is from our 2021 report. Our 2022 data will be published at the end of the month. And at the same time, our recycling rate is just 2% for residential films, based on the latest data available from the EPA. In Canada, it's a similar story. The CPP's portfolio represents 13% of plastic packaging in the Canadian market. A little over 1/3 of their portfolio is film and flexible packaging by weight, with multi-materials representing 8% of the total portfolio. Nationally in Canada, film and flex are about half, 47% of plastic packaging that's on the market. And yet the residential recycling rate is just 3%. And is estimated to be even lower for the industrial, commercial, and institutional sectors. The film and flexibles that are recycled in North America today, this is really important to understand, is just monomaterial polyethylene. Here's a peek at some historical pricing excerpted from the commonly referenced index recyclingmarkets.net. Just to answer this question in the chat, thank you for asking it. Residential recycling rate, I'm talking about what's coming from consumers, what's coming from households, from the residential sector, as opposed to material that's coming from institutional or commercial sessions. So thank you for asking that. But to be clear, it's only polyethylene film that's being recycled at this time. Grades A and B, which are clear or natural in color, have consistently higher value than mixed color or grade C. And there's no other measurable foam or flexible recovery at this time in North America. There is no pricing for polypropylene or multi-material flexibles because there are no established markets. And in fact, non-polyethylene films and multi-material films are considered contaminants in the existing recycling marketplace, and when present, can result in the rejection of an entire bale of otherwise decent material. If you're interested in digging into more details on targeted commodities in recycling markets, I encourage you to review the APR and ISRI bill specifications. But the most important part that I want to plant the seed in your mind for the presentations that follow, if there's only one principle I can convey, let it be that if there's no value, there's no recycling. And value creation has to start with design and be sustained by demand. If we're going to realize the goal of a circular economy at scale for these film and flexible materials, they have to be intentionally designed and manufactured to become a valuable feedstock for recycled content. And I realize this is the start of a long journey. It's not a short-term goal, but a long-term strategy, and it's going to take a lot of work together to get there. And I think that taken together, and as you'll see, the Canadian and US Pact design guidance for flexible packaging is representative both of what materials have real value today and what materials will create value that enable the recycling systems that we look to create in the coming years. So with that, I'll hand it over to Pierre to tell us more about how multi-material film hinders circularity.
Thank you, Megan. So I will be brief, and I will need to change the slide first. I will be brief. I've been asked to provide a bit of an overview of what happens with film and flexible when they are collected. So I have just a couple of slides to show you today. Let me start. I'm having trouble with moving the slide. Sorry about that. Let me start with the collection part. And here you have data that were gathered through the PerFlex study and data regarding what composed the actual flow of film and flexible in the garbage and recycling stream in Canada. I will focus in Canada because there is a much more extensive collection system for film and flexible already. So if you look at the very right part of this slide, you can see that the multi-material are composing about a quarter of what is being collected right now in Canada. Multi-material plus material we were not able to identify through an NIR sorting device. I don't have the right number for the US on this, but I have seen several numbers ranging around 20% of multi-materials generated. So, we are pretty much in the same range here. So why is flexible in general and multi-material hard to process in general? I don't know, and I apologize if it's something you know already, but given there are about 400 different attendees, I wanted to, before we dive into the topic of why it's difficult to process, just how material flow in general in a MRF, and more specifically film and flexible. So in a single stream MRF, you start with the pre-sort where you remove the residue and the large items, and then materials go into mechanical separation that generally include a 2D, 3D format separation. 2D are generally paper, while 3D are generally containers. So you have two lines, and on these two lines, you have other sort of sortation. I hear a question. No. Other sort of sortation, including manual picking and optical sorting. So film and flexible basically flow everywhere here in that chart, which is again a very general overview of what happens in a MRF. So the MRF operator need to have several catching points of the different flexible along all the process. So many different type of catching points and many different type of flexible type of packaging, as we have seen on the first slide. And there is no MRF that are making different type of flexible plastic bales. So like, for instance, making a bale of PE only, then a bale of PP only, then a bale of multi-layer on. At best, what the MRF will do is that they will make a mono PE bale and remove the rest, PP multi-layers, and consider those as contaminants. But there is still, and the Experiences Canada is showing, we still have a lot of multi-layers in the flexible bales that the reclaimer receive. And only very few of them are also equipped with optical sortation at the very front end to remove those. But even if they do, even if they have optical sortation, and some of them have, there is a lot of challenge, as it was outlined recently by a CFLEX study, and I won't go over the list from that report. I will put the link in the chat right after if needed. But basically, when it comes to multi-material, the optical sorter are generally able to view the dominant layer and recognize that and sort that specifically. Any other layer that could have an impact on the recycling could or could not be recognized, and that would have, again, an impact on the further processing activities. So the sortation is needed because otherwise it could impact the recycling process, as I have mentioned. You might have some layers that have more or less impact, and I put here the PVDC as an example, which is the most basic one and the most famous one maybe. But the main technical challenge when it comes to recycling is that basically the resin in the multi-material are just not compatible in an extrusion process. So at the end, say that you are able to sort the multi-material to prevent the impact to recycle other flexible plastics such as mono-PE. And say that you are able to make a pellet out of the multi-material feedstock that you have. We need to keep in mind that there is still a very low demand for that type of pellet, a mixed resin pellet, apart from plastic lumber, which is used, for instance, in park benches. But I think we can agree that there is a limit on the quantity of park benches we can use and make every year. So basically, there is low demand for that type of product and low value. You raise the demand, you raise the value, and you raise eventually the capacity of the MRF to sort out the different type of flexible in an efficient manner. I did not cover, as you can see on this slide, the chemical recycling because the next presenter, Sarah Edwards, will do so. And Sarah, the floor is yours.
Great, thanks, Pierre. Yes, so I'm Sarah Edwards. I'm the president of Eunomia Research and Consulting in North America. I've got the very simple task of trying to provide some information as to whether chemical recycling will be able to expand the accepted materials, effectively materials that might be collected through our curbside or other source-separated collection options. As I said, this is no small task, so I'll just give you a quick overview of what I'm going to be presenting today. It's just a small part of some of the work that Eunomia does, but Eunomia is effectively an environmental consultancy that's been working on circularity for about 21 years. And probably for the past 3 or 4 years, we've been looking at some of the options to address some of these more difficult to recycle materials like film and flexible packaging, with a specific focus on the emerging technologies in the chemical recycling space, chemical advanced recycling, whatever different people call them. So the body of work we've done is actually built on the first piece of work we did with ChemTrust in Europe, which was basically giving a state of play of chemical recycling technologies, and that was back in 2008, I think, 2020. And following on from that, we were appointed by the Alliance to End Plastic Waste to look at some of the barriers to enabling chemical recycling to be part of the value chain solution and helping those technologies scale. And that piece of work is what I'm going to talk to you about today. That's focusing on what do a certain specific type of chemical recycling process need as a feedstock that maybe some of our MRFs can start developing outputs for, following on from what Pierre said. Currently, only polyethylene really is sorted for recycling currently and mechanical recycling. So what would the specification of a bale potentially for a chemical recycling need to be as an output from either a primary sorting facility or a secondary sorting facility? So this is the report I'm going to talk to. So it's basically, and I'm going to go through the methodology and the approach that we took, and then some of the findings, and then loop that back into what that looks like in the context of the film and flexible packaging stream in the US today. So first of all, as I said, chemical recycling technologies are, there's a range of different technologies that form part of this kind of wider technology scope. There's solvent purification, which is basically a technology that kind of selectively separates the plastic polymer from the other materials. There's chemical depolymerization, effectively using a chemical to break down the polymer chain. And then lastly, there's thermal depolymerization. And this is the type of chemical recycling that we often talk about when we talk about things like pyrolysis. So it's that thermal depolymerization process that the study that I'm going to provide insight to today covered. So first of all, just an introduction to the work that we did. So this work was commissioned by the Alliance to End Plastic Waste, and we worked very collaboratively with them to understand, first of all, what the objective and scope would be for the project, and I'll come on to that in a moment. Effectively, what was the problem definition, and where we started was very much like how can we enable these chemical recycling to play a role in the value chain to increase the recycling specifically of polyolefin material. As part of the work, we carried out a literature review. So the first thing we needed to do was understand where the chemical recyclers were. And then as part of that, we then carried out some detailed questionnaires, surveys with those identified technology operators, and in-depth interviews so that we can get an understanding effectively of what material they would accept at their facilities and what are some of the contaminants that they would have to manage, as well as some of the factors that would impact on the specification of the material coming into the facility. And lastly, obviously, once we had that data, everything was covered under NDAs. We had to review the data and then start looking at some trends and some similarities so that we could start to develop this guideline specification. And then once we'd done that, we could test it with the organizations that had provided us with data. So when we were developing this scope and the definition, there was two kind of key areas that we identified with the Alliance to End Plastic Waste that needed to really be challenged to understand the role of chemical recycling. The first really is, which is what I'm going to talk to, was the lack of transparency of feedstock requirements. I think most of the industry is very aligned around either European or US standards, bale specifications for different plastic grades as provided by APR, for instance, in the US. But there's very little understanding of what that means for material that's flowing to a chemical recycler. The other barrier, which wasn't really addressed in this work, but is clearly still a barrier to scaling of chemical recycling technologies, is really a lack of clear regulatory framework that allows for chemical recycling and provide, while ensuring there's obviously those environmental and social safeguards. So the work very much focused on how do we unlock some of this lack of transparency in terms of feedstock requirements for this technology, and had a focus just on two thermal processes, the pyrolysis and gasification, and kind of aligned to this presentation today, it focused on polyolefin waste. Unlike what we've been speaking about earlier today in this webinar, it covered both rigid and flexible polyolefin materials, so LDPE, HDPE, LLDPE, and polypropylene. So as I said, we carried out secondary research to identify the recyclers that were currently in operating, understanding some market data, and once we'd identified both the recyclers, chemical recyclers that we could talk to, as well as some of the other market players, we carried out some primary research, including through interviews and surveys. As part of this work, we found it was very important for us not to speak just to the chemical recyclers, obviously, but also to understand the view of mechanical recyclers, so what materials they were able to take, as well as the waste management companies and sorting facilities that would be producing these bales for processing by chemical recyclers. And across Europe, we also spoke to some of the PROs that manage some of that material that are coming through from collected from household household and residential materials, as well as industry associations. So as part of this, we spoke to APR, we spoke to CTO in France, we spoke to Viridor in the UK, and Merlin Plastics, EFS, and Waste Management, which is a few of the stakeholders that we spoke to as part of this research. This slide basically just gives you an overview of the number of companies that were contacted and the response rate. Not surprising that it was very difficult to actually access data and have those conversations with some of these emerging technologies. So in the end, we actually had responses from 5 pyrolysis facilities and 2 gasification facilities. When we looked at this data, obviously we recognized that probably having information from just 2 data points on the gasification piece was insufficient for us to kind of come to any conclusions, and that we could pull into a specific specification or guidelines for gasification. So the research very much focused on consolidating and analysing the information that came through the pyrolysis operators. So the evaluation process took a number of different steps. So we basically looked across the information that we were provided confidentially to find where there was commonalities, defining the best formats for the different technologies, and reviewing the specification with the industry as we went along. Obviously, the interviews were enable us to clarify the information that was received, and because this work also was looking at facilities not only operating in North America but also in Europe, we looked to find out if there was any regional differences to what we were hearing. I think obviously one of the main takeaways is that this technology is still very much emerging in the context of managing polyolefin materials from post-consumer sources. So, as with all specifications, there's always going to be an element of contaminants that need to be avoided in order to enable off-takers and recyclers to use that material. So these were the categories effectively of contaminants that were raised within the work that we did, and they fall into these broad buckets. So PVC is a contaminant that effectively introduces chlorine atoms to the process, and this has a corrosive effect on the technology, obviously impacting on the cost and maintenance costs of those facilities. PET, EVOH, and nylon contains oxygen, so this is a chemical contaminant effectively that will reduce the yield of the resulting pyrolysis oil, and has a negative impact on the quality, which obviously then impacts on the ability to sell that material and the cost of that. Polystyrene was a contaminant that came up often, but across the different chemical recyclers that we spoke to, had a very different tolerance level between the different entities that we spoke to. So there's very high variation in terms of the level of polystyrene contaminants that were acceptable from the 5 facilities we spoke to. Metal, glass, and dirt obviously has the ability to not only be abrasive to the equipment, it's very heavy. So in terms of if you've got a large amount of this material in the feedstock coming into the process, you're effectively paying for weight, but material that has no value. It can be removed obviously through pre-sorting and from washing and shredding, but obviously that does have an impact on the cost of the facility and its operation. And then lastly, paper and organics, again, similar to PET, contains oxygen, so has an impact on yield and quality of the pyrolysis oil. I think there's probably lots of questions, but I'm probably going to run over, so I'm very happy to try and answer them in the next session if one of the next speakers talking, if that's good. So there were the main findings in terms of what the contaminants were, and the other 2 factors that we did look at was the size of the material, and that generally wasn't a problem. There's normally some shredding and washing at the shredding and drying at the start of the process. And the other one was moisture, which again is not ideal because it increases the weight of the material coming in, therefore increasing the cost, but clearly has a cost implication. When we looked at these contaminants and some of the other factors that were affecting, I suppose, the ultimate specification from the information we received, there's a few factors really. So those facilities that had an element of pre-sorting within their capability were able to take kind of a looser specification with a greater amount of some of those contaminants. Obviously, as a result of that, they would have a lower gate fee or tipping fee at their facilities. They're effectively sourcing lower quality material into the facility, carrying out the cost of sorting that at their own facility before putting it into their process. If they didn't have sorting, pre-sorting, then effectively the pre-sorting needed to happen before, so they had a much more stringent and more prescriptive requirement on their specification. The other factor that affected, you know, the feedstock that they were sourcing was any post-treatment. So this is of the pyrolysis oil. Again, the more post-treatment there was, the less stringent to some extent the feedstock specification was. And then if they, you know, the requirement of the off-taker, effectively the requirement of the cracker that would be taking the pyrolysis oil also impacted on the amount of, to some extent, the processes I mentioned before, the pre-sorting and post-sorting that need to be done, and therefore the specification. And obviously all this comes down to the value equation and the cost that you can both source material for as well as the revenue you can receive from the pyrolysis oil. I think it was fair to say that at the point of this study, though, you know, most of the pyrolysis operators that we were speaking to were still going through processes of refining their desired feedstock specification with mind of what markets were asking for. So what is that resulting? So the specification that's presented in the work and from outcome from our study was very much looks like this. So effectively we were looking at a bale, a specification of a minimum mix of polyolefin PPE of 85% and a maximum obviously contamination level of 15%. And then that the precise composition of that contamination was reflected in the main contaminants that I just highlighted. So contamination for PVC was capped in most cases around 1%. There was variation, but that's kind of the general guideline that we came to within reviewing the work. PET, EVOH, and nylon had a maximum of 5%. Polystyrene 7%, and then like the metals rigids around 7% as well, and 10% of organics with moisture content like aiming to be around 7% or less, obviously. So how does this compare to current specifications, I suppose, on the market? I've just highlighted here specifications of some other plastic grades. And as you can see, I mean, the main point, I suppose, here is that the pyrolysis technology can take a polyolefin mix, so PE-PO blend, and to some extent with small amounts of multi-material metals, where compared to like the current specifications for like PE retail films and LDP color films. And that mix of polyolefin blend is obviously something that's very beneficial to the flexible packaging stream. There is also some level of enabling some level of contaminants that can go into that, slightly less stringent than some of the other specifications. So lastly, a couple more slides for me because I'm probably over. I think one of the key takeaways was really that pyrolysis operators and that have a feedstock specification that they need to meet. It may be slightly less rigorous than mechanical recyclers, but both effectively are targeting a clean and consistent stream of polyolefin material, and pre-sorting in most cases will be required. The potential of pyrolysis to complement mechanical recycling, specifically for the processing of polyolefin films, was highlighted throughout the research by those chemical recyclers we spoke to, and the composition of multi-material films is currently problematic for pyrolysis. So we talk about multi-material, multi-layer, but what they're looking for is multi-polyolefin mix materials with some of those other, some of the barrier layers that might be needed on some packaging material to be removed. And then there needs to be greater effectively investigation to identify pathways for supplying facilities feedstocks, which I think, you know, we've touched on a little bit today, but clearly more work needs to be done so that these technologies can be complementary. And policy is probably going to be critical in the supply of material moving forward. How am I for time? I'm probably way over. Yeah. Shall I think I'll just do my last slide. So this is just a bit of an overview of the film and flexible packaging market in the US today. I think the main point to say is we've got, oh, maybe move forward, sorry. One more. Currently, a large amount of the film and flexible packaging in the US is polyethylene, but that is predominantly the film. If we look at some of the packaging materials, which is the form-filled seal and the pouches, majority of this is multi-resin or multi-material. And if you look at the, which could in part be an option for supply for pyrolysis. But if we look at the bar chart on the right-hand side, actually that currently that only multi-material resin, multi-resin polyolefin is actually a very small percentage or amount of that residential and commercial sector material. So there's a long way to go effectively to transition some of the multi-material multi-material flexible films into a format that's suitable for chemical recycling or pyrolysis specifically. So with that, I will lastly pass it over to Paul, I think, as I'm running out of time. Sorry, Paul.
All good, Sarah. Thanks very much. Paul Shorthouse, I'm Senior Director with the Canada Plastics Pact and a key team member supporting the work on the flexibles that we have ongoing at the CPP. I want to just, we're going to transition the conversation now into obviously, we've heard from the recycling side, both chemical and mechanical recycling, that there is a preference for more mono material or at least clean stream polyolefin, PE, mono PE, mono PP where possible. And one of the big focus of much of the work of the PACs is to harmonize and align around the opportunities to move to more mono material structures. So just to share that as we've already heard, moving to mono material can really help to eliminate the risk of contaminating the sortation stream and make recyclability easier to achieve and increase the value, as long as the redesign is done, properly based on the product or the performance requirements of the packaging. So I'm going to speak a little bit about how we're working to harmonize some of this effort. It really does come down to the importance of design and looking at how we can work to align around a common set of standards in this space. So I'll speak a little bit to some of the guidance documents and overarching materials that are available to help with that alignment here. Sorry. So I wanted to just touch on the Golden Design Rules, which is a high-level framework that we are working and following here for the Canada Plastics Pact. Really, the Golden Design Rules were developed by the Consumer Goods Forum and their Plastic Waste Coalition. The Consumer Goods Forum brings together the CEOs and senior leaders from 400 retailers and manufacturers across 70 countries, companies with a combined annual revenue of 4.5 trillion. This is a major sort of market movers in this space. We have, as many will be familiar with, 9 golden design rules that provide a clear framework that aims to drive innovation and result in less plastic packaging that can be more easily recycled at the end of the day. Golden design rule number 6 is where it's focused on increasing the value of flexible plastic packaging by moving to more monomaterial structures. And we'll talk a little bit more about what that means. But we're also aligned with at the CPP and the US Plastics Pact with the Association for Plastics Recyclers guidance, which is a more technical and complementary to the GDRs. But they provide critical guidance protocol, and it's used to assess the compatibility of PE-based films and flexible packaging with film reclamation systems, and also expanding now to look at polypropylene as well. So just to say that we are working across North America here to align around that. And I wanted to share a few of the key considerations that are most important for moving to monomaterial as you're thinking through your packaging. So really at a high level, that shift to monomaterial has to consider and be able to satisfy packaging performance requirements first and foremost. Obviously, it has to satisfy environmental considerations. Ideally, it's compatible with existing equipment and production lines as well. There may be costs for retooling. So how do we minimize those costs, and how can we think through the equipment lines and their operation? It has to satisfy packaging effectiveness, so consumer safety and preferences. And there's also an importance to consider, your stable supply of the polymers that you would be using as you look to move your packaging to sort of more monomaterial in that sense. There's, I think, two high-level considerations. We know today that both multi and monomaterial flexible packaging are widely used for food-related applications. And so thinking through the two most important considerations here for food packaging and that transition to monomaterial flexibles is, first of all, the modified atmospheric package or the gas barrier requirements. And secondly, your cold supply storage considerations. So with respect to kind of the first one, the MAP, it's a system that essentially changes the gaseous atmosphere surrounding the food product inside the package for food preservation. And monomaterial packaging can achieve moisture barriers, including when you're using 100% polyethylene with high barrier grades. But to achieve MAP barriers with a monomaterial structure, it's often requiring a thin barrier layer of other materials, which is necessary. And we'll talk a little bit more about some of the innovation that's going on there. I think in addition, as I mentioned, the other consideration is the cold food storage or supply chain. And just with respect to that, considerations for PE and PP films, they have a low glass transition temperature, which means it allows them to be ductile at cold temperatures, so minus 23 degrees Celsius or minus 15 degrees Fahrenheit. And because of their frozen condition, it often negates the need for a gas or moisture barrier. And we see a lot of common applications of frozen foods for that reason in monomaterial packaging today, including things like frozen vegetables or French fries, to give you a sense. In the other aspects, so non-food applications, the non-food items are more easily placed in monomaterial flexible packaging. Non-food types typically do not need that gas barrier. And so, in many cases, it's an easier transition to a monomaterial package. PE and PP are used to package many household items that you're familiar with, like liquid chemicals and industrial products or home goods, because of their good chemical resistance, such as cleaning and soap dispenser refills or motor oils or personal care items and creams. The packaging design, though, has to be optimized to ensure abuse resistance and product retention. So those are a couple of considerations from respect to the non-food items. There are three sort of additional considerations that I'll just touch on briefly, in addition to sort of the general food and non-food considerations. So performance being a key one, as I mentioned earlier, manufacturing and production considerations, and lastly, marketing. So some of the key questions that brand owners or manufacturers or retailers should be asking themselves or thinking about related to performance include what barrier properties are really important, what convenience features are essential for the consumer or the customer, what are the sort of transportation and shelf life considerations, and also sort of what durability or abuse resistance is needed in that sense. From the sort of manufacturing and production side, so key considerations here include the filling format. So is it a pre-made format or a form fill seal? The pre-made pouch equipment lines offer better control and are therefore more suitable for monomaterial. There's equipment and line settings and speeds, which we talked a little about earlier. So depending on the material, the line speeds may be affected obviously by the heat resistance of the material in use. There's a lot of innovation going on in this space to address some of this. So we'll be talking and digging into more of that during the workshop series. And then also product testing requirements. So abuse resistance targets for each product obviously have to be determined, and the packaging designed to meet those tests like drop and puncture, which will likely require some field trials or testing in that sense. And then the last area is around sort of the marketing side of things. So key considerations to think about here include look and feel. So the user experience, how is the package or brand presented to the consumer? Does that change as you think about monomaterial? Will the product be utilized at once or over multiple different times? And is it sort of resealable, flexible package essential for the consumer? How do you consider those different sort of trade-offs in that sense? And then lastly, from these sort of retail shelf considerations, is there a shelf life to the product that might be impacted? How can the products fit on the shelf, and how are the competitors presenting their products on the shelf? And what are the considerations there for when you shift to a mono material and its look and feel? And then sort of on-pack labeling considerations as well. Can the mono formats work in accordance with branding requirements, or can those be adjusted? And other considerations around compliance with certain standards, like how to recycle labeling. So, and I'll just mention that this is a lot of information I've covered in a short time, and it's fairly high level, but it's all summarized in our guidance document that the Canada Plastics Pact published last year, our Pathways to Monomaterial Flexible Packaging. You can scan the QR code here or download it directly from the CPP website under our guidance document section, but I'll also put a link into the chat box here. It covers a lot of the information that we've just talked about, and also a little bit more. There's more technical guidance at the end, and it's really designed to provide benefits for these different users, including manufacturers, producers, brand owners, and their marketing departments that we realize have to be engaged in this process. So I'll wrap up here. I'm going to now pass it back to Megan and also to Rebecca from Amcor, who will speak more to some of the technical considerations as we think about the guidance documents around the Golden Design Rules and the APR. So over to you.
All right, thank you, Paul. So I hope you saved some mental brain power. We're going to get into the technical details and talk through some of the nitty gritty that all packaging designers love, right? So first and foremost, we're trying to help you and equip you with really the knowledge that you need to be able to move forward and design your packaging for circularity. And as Megan mentioned, recyclability is certainly a piece of that. So the US Plastics Pact has their own playbook around recyclability. Paul just talked about what the CPP has. And I just wanted to note that we're focused on flexibles here today, but all of the common North American recycle streams are also included in this playbook. So definitely make sure you're up to date with that, and you are able to not only design your flexibles, but other formats as well for recyclability. Okay, so let's get into kind of the guidance that both packs kind of have rallied around. And I think you're going to see that it's very well aligned with what Sarah mentioned as well. So in general, what we recommend is mixed polyolefin structures, right? So over 90% polyolefin content, with polyethylene being the most preferred option. So moving towards mono polyethylene. And there's been a number of questions around why polyethylene is kind of the winner of those three options. And really, it's been stated a few different times, but essentially we're encouraging mono polyethylene because that's the most developed stream that consumers have available to them across North America. Once mono polypropylene and maybe even mixed polyolefin get that infrastructure and that structure for the system around them, those are perfectly acceptable as well. That said, there are certainly some things where a mono PE structure is just not going to be feasible. And so it's important to be taking steps for the future and moving towards mixed polyolefins if you need to. All right, so that's the first thing. Metallization is okay. In terms of mechanical reprocessability, there's not really a ton of detriment. Obviously, you're going to get discoloration, but it's not a huge issue for reprocessability. However, it does need to still sort, right? We need to make sure that it gets through the system and can be reprocessed. So that is one thing to consider. And there are tests out there to make sure that your structure does sort correctly. Attachments, I saw we had some questions around that. So things like spouts, zippers, fitments, any of those types of things should match the base resin of your package. Most common things were always polypropylene, right? Because they have a lot of fatigue resistance, really a great design. But now there's been a lot of innovation in that space, and there are mono PE structures available in most of those areas, if not all. So really push your suppliers to make sure that you are able to meet those requirements because they do exist. And then we'll dive more into kind of what types of barriers are acceptable, because obviously we want to make sure we're keeping the functionality of these packages. But there are acceptable levels for common things like EVOH, nylon, even polypropylene in a PE structure. So we're not saying, even when we say mono material, there are going to be other materials that are acceptable as long as they're under those threshold limits or tested for compatibility. And EVA and other copolymers are also listed there. So you will see as we dig into more details that there are, it's more than just polyethylene listed. Okay, so what's not allowed? This is pretty unanimous across most guidelines, I would say today. Things like PET, PVC, PVDC, paper, aluminum foil, anything that's going to be making the material degradable, whether it's marketed as degradable or compostable or any of those things. We don't want those in the recycling stream for a lot of reasons. And on top of that, you need to also be considerate of the labels you're putting on, right? So right now, paper labels are accepted. They're tolerated in the recycling stream, but really we'd like to move them towards PE labels for a PE structure, right? Moving away from paper, because it is a big contaminant for the recyclers. And this is, again, pretty general. You'll see when we compare them that this is a pretty standard list across all recycling organizations. So here's the details. Here's where we really get into it. So we've taken, a few different organizations that are commonly followed for recycling guidance around the world, right? So North America, we have APR. We've referenced them a number of times already today. They're going to focus mostly on PE. So we'll talk a bit about that. Then in Europe, we have kind of APR's counter, which is Recyclas. So we're going to go through some of the differences there. CFlex is an industry organization in Europe that's specifically focused on flexible packaging. So we'll go through kind of what their guidance looks like and how it compares. And then, as Paul already mentioned, the golden design rules, or the GDRs. And you'll see a lot of commonality there. I think you can see that there are some best practices that no matter, what region you're designing for, you can pretty comfortably follow these guidelines and be able to have kind of some harmonization across your packaging structures. So first and foremost, all of these are really focused on polyolefins, or, as I mentioned, in APR's case, PE. And that means that in order to get through the system correctly, we need to make sure that the density of the structure is less than 1, right? They have to go through, in many cases, they have to go through some kind of sink float. So we want to make sure that we're keeping our structures less than 1. That means you need to be cognizant of anything inorganic you're putting in there with fillers, pigments, things like that. In order to maximize the quality of the PCR that comes out for mechanical recycling, we want to try to minimize any printing and pigment in general, right? We all want to get PCR back that's, clear, just like virgin. I mean, ideally, and that's the way to do it, right? Is to try to minimize what is going to be a contaminant in those structures with colors and pigments. We already talked a bit about the attachments. We want to make sure that they are going to be made of the same material as the base resin. As I mentioned, traditionally these were mostly polypropylene, but there are a lot of PE versions out there now. So make sure that you are pushing your suppliers to get those attachments switched over. And a good note here is that we know that consumers won't take those types of parts off. We're doing a lot of work to make sure that they stay on for the life of the package. We don't want to make the consumer have to take them off. So they will need to go through with the film in the recycling process. Okay, so preferred materials, APR is going to be polyethylene only, because that's really the well-developed consumer recycle stream here. In Europe, Recyclas has standards for polyethylene and polypropylene, as well as test methods around both of those. So they're also kind of zeroing in on those two materials. And then both CFlex and the GDRs are really stressing preferably mono PE or mono PP, but they do allow mixed polyolefins for both of those, right? And you can see the percentages there, very standard to what we've been talking about all along. All right, when we get into the allowable materials, it gets a little bit more varied, but you'll see there's still a lot of commonality here as well. So again, for the PE stream for APR, we're allowing EVA, which is commonly used. It's a copolymer commonly used in things like retail bags, polybutene, which is a common material for easy opening features, right? So when you're peeling it apart and you can do it with your hands without a scissors, that's often contaminated with PB. Ionomers, another common material used, also a copolymer of polyethylene, no problem. Siax and ALOX and metallization, all of those are inorganic barrier coatings that are used in very thin amount, very small amounts, and usually fine, with the exception that the metallization needs to sort correctly. All right, so we have a few things that need testing for APR. That includes polypropylene, EVOH and PVOH and nylon, which are all barrier materials. So you need to make sure there's no specific guidance around those yet from APR. You'll just need to go through, again, the critical guidance testing that Paul mentioned to make sure your structure is compliant for those materials. For Recyclass, it's a very similar list, as I mentioned, with the change that polypropylene, EVOH, and nylon have a limit, right? So they're acceptable up to 5% without any kind of testing, and PVOH has a limit of 1%. So that's PE film. PP film, again, we can do PP copolymers, plastomers, things like that, as well as Siax and ALOX. Again, PE is a contaminant in that stream, remember, so you can use that up to 10% and EVOH up to 5%. And then C-Flex and the GDRs are much more general, just any of those barrier type materials up to 5%. And again, that's really because those are general guidelines versus the APR and Recyclass have really gone through, and the reason they have more prescriptive limits is because that's based on previous test results that they've seen, and they've actually shown compatibility up to those limits. As we move down, prohibited materials are very similar across all of them, right? And it's based off of what we already talked about, right? We don't want things that aren't going to melt in the extruder with polyethylene or polypropylene, right? So things like PET and copolymers thereof are often going to be at higher melting points. We don't want things that are going to degrade the quality. So degradable additives of any kind or compostable materials will be a problem through that system. There's a few call outs from Recyclass and C-Flex about foaming other materials, right? And that's going to mess with the density and potentially contaminate. It would be a way that you could potentially have something with a higher melting point get into the PO stream. So we don't want that. And then the other one I want to point out is Recyclass does not allow nylon in their polypropylene films. So that's something else to just note. Now, again, the one thing to know, and we mentioned it slightly, is that APR is working to move towards having design guidance around polypropylene. And it's likely going to be very similar to Recyclass because Recyclass and APR are actually in the process of doing some harmonization across those two organizations. So we should expect to see a bit more of that in the future. And you can see there are a few, upcoming updates for the GDRs over the course of this year, and additional information still coming out of C-Flex around their D4R project. So all of these are kind of still in motion, and that is why we wanted to provide you with all of the links where you can go and access them live, right? So again, some of these were published once, but they are updating right now. Some of these are constantly updated, right? So specifically like APR and Recyclass are updating them as more data is available. So we want to make sure you're equipped with all of those. So go ahead and you'll find all of the links you need right here. All right, and with that, I think we are ready to take some questions.
Yes. All right. Well, first I want to say thank you so much to all of our speakers. This was great content. I also want to say thank you to everyone who has hung with us through this. These are pretty deep topics, and the chat has been awesome to watch and to try to keep up with. So thank you all. We've got a bit of time here for some Q&A, and so I have copied some questions from the chat. The first one, I think our most commonly asked question is yes. The answer to the most commonly asked question is yes. We will send the recording out afterward to everyone who registered for this. It was a lot to digest, so you can go back and watch it again, to catch anything you missed. Please go ahead and continue to put questions into the chat. We will answer as many of them as we can. So I've been trying to keep track of which ones have and haven't been answered. And we'll go ahead and get started. So kind of starting with a more general question that has been asked in a few different ways, and I'd like to have both the Canada and the US perspective on this. As we think about, collecting film and the cost to have it go through MRFs and the different contamination issues, what can we have both the US and the Canada, both of you answer, what are you seeing as far as increasing collection rates for film and flexibles, especially coming through MRFs, given that it is rather expensive to sort everything?
From Canada's perspective, I may also invite Pierre to join us again in the Q&A portion of this discussion. He was one of the lead authors on the Perflex study that we commissioned, which really understood the growing sort of market, in line with some of the EPR, extended producer responsibility targets and goals for flexibles and films that are evolving in Canada, especially Ontario, Quebec. And it does profile the demand, the increasing targets and requirements that MRFs are going to be facing in the near term. Pierre, are you able to speak to that just from the Canadian perspective?
Yeah, can you maybe rephrase the question? It cut a bit on my hand.
Yes, can you talk to how you anticipate growing collection through MRFs or other channels, particularly given the cost of sorting this material out?
I think this is an ongoing topic through the Perflex steering committee to define what are the best approach in terms of collection and further sortation. To be quite honest, the only thing that at least I can say is that with the EPR regulation as they are set out with very strict and I would say ambitious targets in terms of collection and recycling, it's hard to think about another way of collecting the flexible to reach a 50% collection target, for instance, besides collecting this by curbside recycling. But yes, I'm not sure if that answered that question, which is a very broad question. And if someone has a miracle solution, please raise your hand. Would be happy to talk to you. But it depends on so many different parameters within each jurisdiction. So yeah, fortunately, I did not respond well to that question. I'm sorry, but I'm happy to chat further.
Maybe I can add, though, that the Perflex study did highlight that the role of the MRF should be to be able to collect as much of the flexibles and films as possible through a preliminary sort, but that secondary sorting of PE or PP or multi-materials is best to happen at the recycler itself or at the reclaimer, in a sense that investing in the sortation technologies for that secondary sort makes more sense post MRF.
Can I touch on that as well? Is that good? I think obviously I think what's highlighted in this discussion is there's no easy answer, and there's a lot of work being done to try and find the optimum solutions. But I think to some extent, there's a lot of MRF concern around not necessarily just flexible packaging, but actually flexible film. And then UNOMI has recently been doing some work in Colorado on its needs assessment for EPR, and some of the you know, some of the feedback has been very much there's a big reluctance to accept film, because film actually gets caught around equipment and has a health and safety impact. But then if we look at flexible packaging, there may be alternative solutions. I agree with the point that, you know, curbside collections are going to obviously have to be key, but even under curbside collections, we have to be cognizant about how much we're going to be able to capture. And just, you know, from our knowledge of collecting other materials and other plastics, you know, specifically through single stream, we know that there's challenges in even getting high capture rates and high collection rates for those materials. So it's going to be tricky. And then we can look, you know, to some of the research and work that's been done in Europe. So FOS Plus, which is the PRO for Belgium, has had quite significant infrastructure investments to try and capture this material through its curbside services. They have a collection service that's based just on collecting like containers and films. So the glass and the fiber are outside. They effectively have a kind of 3-stream or 4-stream system. So they're better able to manage those materials as a mix of stream. But even there, they're struggling to find specific end markets at the moment, but at least the collection is taking place, and they do have some end markets. And then in the UK, there's a program looking at various different options, because film and flexible will be included as a requirement under their curbside systems from 2025, I think. So they're looking at a whole suite of ways of collecting it, both through curbside and also store drop-off. So there is increasing amount of knowledge and understanding, I think, but you know, we just haven't quite like pinned the tail on the donkey, I suppose.
Did you want to add to that, Sam? I know you're deep in the weeds as a producer responsibility organization here in Canada.
Yeah, hi everybody, Sam Baker from Recyclability. So we've been collecting this flexible plastics material for 5 or 6 years now, and we've currently today it's all through our depot network. So essentially everybody in the province has access to a depot, and through that we see between 20-25% capture rate of what's put onto the marketplace, which is pretty low if we're trying to get to upwards of 40 or 50% capture rate. So we did a pilot about 2 years ago in a municipality in Vancouver, where it was a curbside set out of segregated stream. So put it all in one bin, its own bin. And there we saw a capture rate 3 times higher than what we get at the depot. So while the depot is great and allows us to keep this material segregated and therefore reduces the processing cost significantly, it's just not convenient enough to the resident to get those high capture rates that we as pros need to meet our targets. So that's one aspect of it. The other aspect of it is, you know, processing is very tricky and difficult. Can you collect it as a segregated stream from the curbside and do away with that need to sort it from other material at the MRF? That might be easier in a multi-stream system versus a single stream system. You know, but there's maybe other ways to look at it for single stream systems as well. So lots of work, lots to test and consider, but that's what we're doing with the Perflex project and here in BC as well.
All right, thank you all so much. And I would be remiss if anyone on this call thought that we're saying just design it correctly and that will solve all of the problems with film and flexibles. That's definitely not what we're saying. And this is the first of many sessions because this is very complex, but we do know that design starts the process in many ways, because if you don't harmonize on designs, then you've got many inefficiencies and all of these other very challenging areas with collections and processing. So I'm going to switch to a little more to some of the design specific questions, since that's what the focus of today is, but we will rest assured there's many more sessions to come. So this one might be for Sarah. The question was, compatibilization is used for EVOH/nylon for mechanical recycling streams. My understanding is that compatibilization of these materials will not be an option for advanced or chemical recycling. Can you confirm?
I'm not quite sure if I can confirm. I mean, I can say that there is a level of tolerance that can be accepted by, you know, based on the work that we've done. I'm not yeah, if that was a question, I don't know, maybe Rebecca can also touch a little bit on that and passing the button. But there is a
Yeah.
level of tolerance, I think, that can be accepted based on our work.
Yeah, so compatibilizer chemically, I would think would be not the problem. It's the materials that you're compatibilizing with, right? So the EVOHs and the nylons Sarah had in the chart is limited compatibility with those processes. So the compatibilizers itself would probably be fine. It's really going to be the material that you're compatibilizing with that could be the problem for their yields.
Thank you. So what if you have a package, like I think this would be a spouted package, where you have a cap that's large enough to get sorted as a rigid on an otherwise flexible pouch? Thoughts on design decisions for that?
So I think it would be a challenge to sort it correctly, right? But certainly in the realms of PE, like there are all the way from the injection molding grades to the film grades that we use. So you could certainly make it materially compatible. It's really more of a question of how it would sort correctly and if it would land in the right place. So I don't know if that really answers the question, but that would be a very tricky package, I think.
I think something like that, just to add to that, would have to be well tested using some of the testing protocols in the APR design guide, or Recyclability if you're in Europe. There's just so many nuances about how that would flow through the recycling system that you'd have to test for.
So to tag on to that, there were a couple of different questions that on some specific things, including like general guidance on acceptable percentage of metallized content, and then you have this. Can you talk a little bit about why like the testing protocols are out there and we don't currently know like an exact percentage or parameter, and the additional testing is required?
So for metallization specifically, and really any of those inorganic coatings, you're using a very, very small amount. So from a material standpoint, you're using, I mean, we're talking in flexible packaging, layers are already thin, and this is even thinner than any of the extruded layers. So it's a very, very small amount from a weight percentage. So from a reprocessability standpoint, there's no issue. It really comes down to the metallization and if it impacts any type of metal detection in the sorting process, whether it's at a MRF or if it's at a reclaimer. And the issues there, the reason we can't give like nice black and white guidance is because it's very dependent on the package format and size. And I expect that we're going to continue to see more work in this space. I know the APR Film Committee has been looking at that for a few years now. So we may see more prescribed guidance soon, but we're not quite there yet. So that's why you have to test pretty much everything at this point, because we still need more data.
Here's another one. Is there a poly paper ratio that determines whether a flexible package goes into the plastic recycling stream versus the paper recycling stream versus landfill?
This is not easy. That's all I would say. Because we already talked about, right? Paper is a contaminant for all of these processes, whether it's mechanical or chemical recycling that films would go to. And plastic is obviously a contaminant for paper recycling. So really, it's not ideal either way. I would say that as paper recyclability guidelines kind of evolve, we'll see more concrete answers in that space soon. But it's going to be pretty small on both sides, I would say. So if you're targeting paper, you'll be able to have a small amount of plastic. And if you're targeting plastic, you can have a small amount of paper, but again, that's really a problem in the system. It's definitely a contaminant either way.
I think one question that you need to ask yourself as a product producer is, as in a circular economy, you are your own raw material supplier, and especially if you're using PCR. Absolutely use paper if you're okay with black specks in your PCR.
Thank you, Megan. I think you also made that comment to me my very first week on this job. So it's a good point though. If you don't want to buy it and you're putting it into the system, then there's a disconnect in getting the circularity. One last question, and this has come up a number of times. Can we talk about food residue as a potential contaminant, both from a mechanical recycling perspective and then what we foresee from a chemical recycling perspective?
Sure, I'll touch on mechanical. So this is also an area of active research. There's a number of you on the call already that I know are working through an APR working group to figure out what actually is clean and dry based on some of the labeling requirements from how to recycle. So we know already that from a reprocessing standpoint, there doesn't seem to be a ton of impact, except for maybe a nice caramel smell for highly contaminated sugar structures. But we don't know the full system impact yet. So more to come on that one, I would say, from the mechanical perspective.
Yeah, and from the chemical recycling, well, the pyrolysis perspective, what we heard is that it is a contaminant. It can be managed, and it's part of the organics part of the contaminant kind of bucket. And the impact it basically has is it does introduce oxygen to the system, so it basically reduces the yield, the value and the quality of the pyrolysis oil. So clearly anything that increases costs or reduces the ability for revenue is going to impact on the viability of the facility. So can be accepted but not preferred, and there is a tolerance level within the guidelines that we developed.
Wonderful. Well, we are doing a great job of wrapping up right on time. So thank you so much to everybody. I do want to mention that when you leave the meeting, there'll be a brief survey that pops up, particularly asking questions around where your biggest challenges are. We have gotten a lot of input to date from our respective membership bases as to where the challenges are, but we continue to want to bring additional viewpoints and challenges as we develop this series. And so with that, I will hand it over to Emily to close us out.
Thank you, everybody, for joining us this afternoon. As we mentioned this morning, or at the start, this is the first in a series, and the next is scheduled focusing on policy in March. And so stay tuned for timing on that. I know we are confirming some last speakers, and we'll share more on the broader series. And then on the next slide, again, as we mentioned, stay tuned for more for the remainder of the series. Paul shared a number of links from the Canada Plastics Pact specific to film work they have done. And you can also find design information there, as well as design information in terms of how the US Plastics Pact has looked at it, combining what APR and CFlex and Recyclability and the Golden Design Rules have put together. So follow us on LinkedIn if you don't already. Take a look at our websites, and we hope to see you again at our next session. So thank you to our speakers and to all of the participants who've joined us today. Thanks, everybody.
Thanks very much.
Thanks, everyone.
Thank you.